Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, in the previous lecture we have discussed semen. In that lecture we have discussed there are two major types of semen. One is hydraulic semen and other one is non-hydraulic semen. In the hydraulic semen we have discussed this is the semen which become hardened when it is reacted with water or in the presence of water due to hydration, and the best example of this cement is Portland cement or ordinary Portland cement. As well as we have discussed non-hydraulic cement, the cement which does not become hardened in the presence of water but become hardened in the presence of or when it is reacted with the carbon dioxide, which is known as carbonation. After that, we have said that when chemical inputs were changed, then we can get different types of ordinary Portland cement. So we did this and we get different types of cement in which we have discussed colored cement, hydrophobic cement, and many more. At the end of that lecture, we have discussed the machinery which is being used in the cement industry. And first of all, we have discussed excavators. We have said that excavators are being used for digging the rocks which are softer rocks. Then we have discussed that the harder rocks were destructed by different explosive materials or pressure blasting, etc., etc. Then we have discussed dumpers and tractors which are being used for the shipment of rock salts or the rocks. Now we are going to discuss equipment involved in that process. And the first one is plant laboratory or the quality checkers. Raw material from quarry are now routed in plant laboratory where they are analyzed and properly proportioning of limestone and clay are making possible, or in some plants quality checker like gamma metric machine and cross belt analyzers are used to check the quality of limestone. The term bulk material analyzer is the generic noun for that device which fits around a conveyor belt and conducts real-time elemental analysis of the material on the belt. Other names often found for such device include belt analyzer, cross belt analyzer, or elemental analyzer. This product first found popularity in the cement industry during in 1990. So students, in this he just explained that quality checkers check the quality of limestone and the clay. For this purpose, different devices are used like gamma metric machine, belt analyzers. These are the different devices which are being used for checking the quality of limestone or the clay which is shipped toward the factory. And this process or this product or this device gained popularity in 1990s. So students, the basic purpose of quality checkers is to check the quality of limestone and clay by using different devices like belt analyzer or cross belt analyzer. Next one is reject belt conveyor. Rejected limestone after analysis leave from here, good limestone pass on. What it means? Student, when you fed your limestone toward the cross belt analyzer. Now, good quality limestone is transferred toward the plant for the next process. And at that point, there is an extra belt which transfer the rejected limestone out of plant. So, rejected belt conveyor is used for the transfer of rejected limestone from the plant. Now, the next one is vertical ruler mill. For grinding and powdered form is obtained. Vertical ruler mill is a kind of grinding machine for cement raw material, cement clinker, slag and coal slag. It has the feature of simple structure, low cost of manufacture and use. Vertical ruler mill has different forms, but it works basically the same. Students, basically the vertical ruler mills are grinders. They just grind the raw material for cement clinker, slag and coal slag. There are different kinds of vertical ruler mills which are being used for the grinding, but the main use is that these are just used for the grinding, and all the machine work on same principle. And the next one is pre-homogenization piles. Powdered form enter there and then into blending silo. Pre-homogenizing is necessary if the limestone shows large fluctuation in chemical composition when handling large quantities of raw materials. Students, after the vertical roller mills, there are pre-homogenizers, because there is necessary to convert all of those powdered form limestone into homogenized form, because these are now, after the pre-homogenizers, these are now fed into the silo. So it is necessary to convert them homogenized particle. If these were not in homogenized form, there will be large fluctuation in the chemical properties. So students, these are three basic units which are necessary to know. First one was reject belt conveyor, then the vertical roller mills which are used for the grinding of powder or for the grinding of rocks, then pre-homogenizing piles which convert the homogenized powder which is then fed into the silo. Students, as I have said earlier, the homogenized form of raw material will enter into the silo. So our next machine is, or our next equipment is blending silo. Blending silo is used for storing and homogenizing the raw meal. It consists of silo shell, the distributing system, the inner cone, the aeration surface with the discharge system, the central mixing chamber, the aeration system and the dust collection filter. In preparing raw meal, the raw material like limestone, clay and iron ore are proportioned and fed to the raw meal or raw mill, where these raw material are ground and well mixed. However, this mixing is not enough to produce clinker. It simply allows the homogeneous mixing with the help of sliding air. System equalize variation of chemical and physical properties of raw materials and convert low quality raw material into a uniform mixture of higher quality as required for the cement production. Now, the next one is preheaters. Preheaters are used industrially dry kiln cement production plants to heat the raw mixture and drive off carbon dioxide and water before it fed into the kiln. In a preheater, ground raw material meet hot gases rising from the kiln. Students, after passing through the blending silo, our raw material now is in high quality pure form and it is in homogenized form. Now it is its turn to fed into the kiln, but before kiln, this raw material it fed into the preheater where the carbon dioxide is removed by heating. In the preheaters, there are different hot gases which pass through the raw material and slide off the carbon dioxide from our raw material. So students, these were two new equipments which are being used in the cement industry. First one was blending silo, which homogenize our raw material, then preheaters where our raw material become free from the carbon dioxide. Now your mixture or your raw material is homogenized and preheated. It means it is free from the carbon dioxide. Now it is fed into the kiln. Now what happened to it in the kiln we will discuss here. Kiln, heart of cement making process. A kiln is a thermally insulated chamber, a type of oven that produces temperature sufficient to complete the process, such as hardening, drying, or chemical changes. Cement kilns are used for the pyroprocessing stage of manufacture of Portland and other types of hydraulic cement, in which calcium carbonate react with silica bearing minerals to form a mixture of calcium silicates. Over 1 billion tons of cement are made per year and cement kilns are the heart of this production process. So students, what it means and what is the purpose of this kiln? Here we are going to explain. Kiln is a thermally insulated chamber. You can say that kiln is the type of oven that produces temperature which is necessary for the hardening of cement, for the drying of cement, and for the chemical changes which occurred in the cement. Cement kilns are used for the pyroprocessing stages of Portland cement and many other cements. In that kiln, there are different reactions from which we are going to discuss. Calcium carbonate react with the silica bearing minerals to form the mixture of calcium silicates. Students, over 1 billion tons of cement made by this process. So that's why the kiln is known as the heart of the cement production process. So students, in this we have discussed just 3 points. First one is a kiln is a thermally insulated chamber like the oven. Second one, it produces heat which is necessary for the different process like hardening, shipping, and chemical changes. And at the end, he said that there are different kinds of reaction which occurred in the kiln, like there is the reaction of silica with the calcium carbonate, and then he said that kiln is known as the heart of cement production because by the million tons of cement is produced by using the kiln. As the cement passed through the kiln because it is heated there, now it is necessary to cool down your cement. And next equipments are coolers. Either grate coolers or crinkle coolers are used for cooling clinker. Grate coolers. The essential characteristic of a grate cooler is a layer of clinker spread on the more or less horizontal perforated grate through which cooled air is blown. The grate is made of steel and the cooled air keeps it sufficiently cool to avoid the melting or the burning. Clinker cooler. After the cement is dried by the being put through a rotatory kiln and converted to clinker, it is need to be cooled. Cooling tunnels are used to reduce the temperature of clinker from over 2000 Fahrenheit to workable 200 Fahrenheit. These tunnels typically use forced draft fans to push the cooled air through the clinker. So students, don't be worried about the coolers. There are just two types of cooler. First one is grate cooler and the second one is clinker cooler. In the grate cooler, the clinker is spread over the grate, which is horizontally perforated grate, and cooled air is blown through it, and which cooled or clinker. And in the grate cooler, different tunnels are being used, which used draft fan or forced draft fans to push the cooled air and cool down the clinker. So students, it is clear in the coolers there are two types of cooler, grate cooler, or you can say that clinker coolers. In the grate coolers, the clinkers is spread on the grate, which is formed of steel, and air is blown through it, which make it cool. And in the grate coolers or in the clinker coolers, there are different tunnels which used forced draft fans to push the cooled air through the clinker, which make it cool. Now, the cooled cement is fed into different equipments in waves: wave feeders, electronic wave bridges, and the automatic electronic packers. First of all, wave feeders. After the crushing of clinker, it allows the efficient addition of gypsum into clinker in the cement mill. Next one is electronic wave bridge. It is being used for the final wave verification. And the next one is automatic electronic packers. It is being used for the automatic packing. So students, we have discussed one by one different equipments which are being used in the cement industry, like quality checkers, kilns, preheaters, blending silo, and similarly we have discussed wave feeders, then electronic wave bridges, and then automatic electronic packers. So students, these were the equipments which are being used in the cement industry. Now after this we will discuss the raw material used in the cement industry. And if I repeat, then till now we have discussed what is cement, types of cement, then machinery used in cement for the shipment. Then we have discussed in this lecture the different equipments which are being used in the cement industry. Now we are going to discuss different raw materials which are being used in the cement industry. So students, now we are going to discuss raw material used in manufacturing of cement. The raw material or mineral used in the manufacturing of cement are of both natural origin as well as industrial products. The mineral compounds used in the manufacturing of cement containing components like lime, silica, alumina, and iron oxides. But these components are found in needed proportions is only one raw material. What it means, what he discussed in this point, he discussed there are two types of raw material. One is natural and other is industrial. And then he discussed that the mineral compounds which are used in the manufacturing of cement contain the components like lime, silica, alumina, and iron oxide. And he also discussed that these components are very necessary in the needed proportions in the raw material. Now, the next point is, therefore, it is usually necessary to select a major mixture of high lime component with the components which is in lower in lime containing, however, more silica, alumina, and iron oxide. Thus, generally, the two main components of cement manufacturing are limestone and marl, or limestone and the clay. Students, if you understand the first point, then you will understand the second point. I repeat the first point again. He said that there are two types of raw materials, natural and then the synthetic or industrial product. He said that the minerals include the ingredients or the components like lime, silica, alumina, and iron oxide. And then he said that all of these ingredients or components are necessary in the needed amount. So in the second point, he said that therefore it is necessary to select the major quantity of all of those ingredients, like select the component which is lower in lime, more silica, alumina, and iron oxide. So there are two major components which meets those conditions. Those are limestone or marl, or the limestone or the clay. Students, as we have discussed, there are two major raw material which meet those conditions which are necessary for the production of cement. Those were limestone or the clay, limestone or the marl. Now, first of all, the limestone. Calcium carbonate, which is also known as limestone, is widely spread in nature. Calcium carbonate of all geological formation qualifies for the production of Portland cement. The purest grade of limestone are calcspar, which is also known as calcite, and aragonite. Calcite crystallizes hexagonally, while aragonite is rhombic. Students, in this point, he said that calcium carbonate is occur naturally and it is used for the production of cement. He said that there are two major crystallized form or the crystalline form of calcium carbonate are calcspar and aragonite. He said that calcite crystallizes in the form of or in hexagonal form. Then he said that aragonite crystallizes in rhombic form. Now the next point is the specific gravity of calcite is 2.7 and of aragonite is 2.95. A macroscopic granular variety of calcite is marble, it would not be profitable to use marble for the cement manufacture. The most common form of calcium carbonate, most similar to marble, are limestone and chalk. Limestone is of predominantly fine grained crystalline structure. The hardness of limestone depends on its geological age. Usually, the older the geological formation, the harder the limestone. Student, in this point, he said that the macroscopic granular manufacture of calcium carbonate is marble, which is not being used because that is not profitable. The crystalline form of calcium carbonate which is being used is limestone and chalk. And the hardness of that limestone depends upon its geological age. Usually, the older the geological formation and the limestone, or the harder will be the limestone. Now, the last point is the hardness of limestone between 1.8 and 3 of the Mohs scale of hardness. Its specific gravity is 2.6 to 2.8. Only the purest varieties of limestone are white. Limestone usually contain admixture of clay substance or the iron compounds which influence its color. Now the next one is chalk. Chalk is a sedimentary rock which is formed during the Cretaceous period in geological time. Geologically, it is relatively in contrast to limestone. Chalk is characterized by a soft, earthy texture. This property qualifies chalk as a raw material, especially for the wet process of cement manufacture. Since blasting is not required for coring of chalk, and the crushing process can also be omitted. This kind of raw material considerably lowers the cement production cost. In some deposits, the calcium carbonate content of chalk amounts to 98 to 99%, with the small admixture of silica dioxide, aluminum oxide, or magnesium carbonate. Students, listen carefully. In the previous slide, we have discussed that chalk is not a hard raw material. Because chalk is not a hard raw material, so digging and blasting is not necessary here. Because this is not necessary here, so the cement production cost will decrease. He also discussed that in some deposits, the percentage of calcium carbonate in the chalk is 98 to 99%, which include some other compounds like silica dioxide, aluminum oxide, and magnesium carbonate. Now, the last point is, in cement raw material, the lime component is generally represented up to an amount of 76 to 80%. Therefore, the chemical and the physical properties of this component are of decisive influence when to come selecting a method of cement manufacture, as well as the types of production machinery. So students, this was chalk. So students, the last topic of today is mar. Limestone with admixture of silica, clay substance and iron oxide is called as marls. Marls form the transition elements to the clays. Because of wide distributions of marl, they frequently are used as a raw material of cement production. Students, first of all, what is marl? Limestone with the admixture of silica and clay and also iron oxide is known as marl. Marls are frequently used as the raw material of cement production. Now the next point is, geologically, marls are sedimentary rocks generated by the simultaneous sedimentation of calcium carbonate and the clay substance. The hardness of marls is lower than that of limestone. The higher the content of clay substance, the lower the hardness. Sometimes marls contains also bituminous or bituminous constituents. In these points, students, he explained that marls are sedimentary rocks. Their hardness is lower than that of limestone, and their hardness depends upon the content of clay. Higher the clay, there will be lower the hardness. And at the end, he explained that sometimes marls contain bituminous constituents. And the last point is, the color of marls depends upon the clay substance and range from yellow to grayish black. Marls are an excellent raw material for cement manufacture because they contain the lime and the clay component in an already homogenized condition. Calcareous marl of chemical composition equal to that of the Portland cement mixture are used for the manufacture of so-called natural cement. However, deposits of such raw materials are not common. So students, in that point, in the last point, he explained that the color of marl depend upon the content of clay, which is range from yellowish to grey. He also said that marl is used as the natural cement. So students, in this lecture, we have discussed different equipments which are being used in the cement industry, and then we have discussed the raw material, in which we have discussed limestone, chalk, and then we have discussed marl.